Hi, welcome back. Today we're going to look at polynomial identities. So for the first example, we want to prove the sum of cubes. So here we have a cubed plus b cubed, and that factors into a plus b times a squared minus ab plus b squared. And I want you to just notice that we have a plus sign here because it's a sum, but the only minus sign is in front of the ab. So remembering that little tip helps to factor. But to prove it, I'm just going to use distribution. I'm just going to simplify the expression on the right. So let's multiply everything in the second parenthesis by a. So we have a cubed minus a squared b plus ab squared. And then I'm going to multiply everything in the second parenthesis with the b. So we have plus a squared b. And notice that I'm trying to put the terms in the same order alphabetically. Minus ab squared plus b cubed. And what you'll notice is that the middle terms here will cancel. So we have the a squared b, those will cancel, and the ab squared. So we're just left with a cubed plus b cubed. And it's really important to know that it was this minus sign that made everything cancel. So having positive values and then having negative values help to cancel those middle terms. So we definitely proved that the right side looks like the left side with just simplification. Okay, now let's look at the identities. We're going to multiply these we're going to create these trinomials. So first let me just show you what we have here. So we have 2x squared plus y cubed squared, quantity squared. So that means we're having two of these identical binomials. So I'm just going to FOIL it just like we usually do, and we'll draw some conclusions here afterwards. So here we have 4x to the fourth, and then we'll have 2x squared y cubed, and then another 2x squared, because that's the inside, y cubed. And then the last will be y to the sixth, because y cubed times y cubed is y to the sixth. So we know that the middle terms are going to add because they're like terms. So we're going to have 4x squared y cubed plus y to the sixth. Now let's just consider what we're starting with. So when we had, we have it, and I'm just going to write this on the side, we have a plus b squared, okay? So we look at this first term here, and when we look at 4x to the fourth, well, that's just a squared. So we have 2 squared is 4, and then x squared is x to the fourth. When we look at the last term, y cubed, over here, well, that's also squared. So in here, I'm just going to write this a little bit smaller so we have some room. So we have a squared, and then for the last term, we have b squared. And inside the middle, if I multiply these two terms, 2x squared y cubed, we get 2x squared y cubed. But if I multiply by 2, I'll get the 4. So because remember we had two of those like terms. So when we factor the perfect squared trinomial, a squared plus 2ab plus b squared, we'll get back to the factored form. And then if we FOIL it, or use that identity, we can actually quickly simplify it. So we don't necessarily need to FOIL every time if we know that trick. So the first term is always a squared, the last term is always b squared, and the term in the middle is the product of a and b times 2, because we'll always have two of them. All right, so working backwards, and this is why it's really important, is we want to be able to factor using the identities. So remember, when we have two terms here, we're always looking to see what we have. So we have 9m to the fourth. So hopefully you can see right away we have a perfect square, 9. And then we have 25, which is also a perfect square. That's 5 squared. So looking at these variables, they're both even. So that means that we can actually use difference of squares. So I'm going to use the form, remember we know a squared minus b squared. And that factors into a plus b, a minus b. So when we have these two terms, we can actually factor it as a difference of squares. And here we have another difference of squares. So looking at what will be our a, well, it'll just be the square root of 9m to the fourth. So I take the square root of 9, which is 3, and then I divide m to the fourth, or 4, by 2. So this would be m squared. Then I look at the second term, and the square root of 25 is 5, and half of n to the sixth would be n to the third. So that's going to be the plus, and then 3m squared minus 5n cubed. So we have a difference of squares here. And what we could do is always simplify it and multiply it back out. And if you multiply, you'll say 3m squared plus 3 times 3m squared gets you back to 9m to the fourth. 5n to the sixth times negative 5n to the cubed would be 25n to the sixth. So you do get back to the original expression by simplifying. Okay, so the key identities that we want to make sure we're going over, and we're going to continue this week, is looking at the difference of squares, the sum of squares, the difference of cubes, and the sum of cubes. So try to get these identities down on a piece of paper, on a post-it on your laptop, and we want to practice these so that they're almost second nature to you. All right, I hope this lesson was helpful, and I'll see you all in class.